Hi, thanks for everyone for sticking around to the bitter end of the day. So yes, I'm going to talk about both astronomy and medical imaging, and we'll see how far I get. I have a lot of simulation and fun recent work, but we'll see. So before I start, since this is a career thing, I am curious to know kind of what professions you're all interested in. So for the younger people in the audience, answer truthfully whether you're interested. For the older half of the audience, you can say what you were thinking of when you were a kid. So just out of curiosity, raise your hand if you ever wanted to be an astronaut, or you do want to be an astronaut. Hey, that's a classic one. How about anyone who was interested or is interested in being a doctor? It's a good profession. Yay, save lives. How about any archaeologists? People see Indiana Jones, yeah. Any archaeoastronomers? No one wants to study astronomy in ancient cultures? How about astrochemists? Look at that. Biochemists? Biophysicists? Applied computational physicists and theoretical physics? Cool. Astrogeochemists? Ha, gotcha. So these are all examples of sort of interdisciplinary research areas. And it's a new thing. It's not new. Interdisciplinary or pan-disciplinary has been around for a while. But really with the innovation of computers, it's become extremely important to look at the intersections of different areas of research. And I'm sort of going to tell you the story of one such example of an interdisciplinary project. And you'll learn more about my career and what I do through it. And the project's called Astronomical Medicine, and some people, have been seeing me talk about it today upstairs, and you'll get a little more of the story behind it. And one question I've received today is sort of where do you come up with this idea, or how does a project like this start? How do people take something as far away from each other as astronomy and medicine and put it all together? So here's the story. How did this happen? There was in Washington, D.C. a few years ago, a joint NIH-NSF conference, so National Institute of Health and National Science Foundation. And the whole point of the workshop was to bring scientists from all different domains together to talk about visualization. And sure enough, there were two people in attendance, and one of them talking. There was Alyssa Goodman, who's on the top from astronomy. And she's an astronomy professor, and she was talking about the challenges in astronomy visualization. Well, in the audience was Michael Halley, pictured in the bottom, and he is from the field of medicine and medical imaging. He was simply sitting in the audience, and she was showing these images and saying how astronomers have trouble with 3D data. This is new data. We have no technology to analyze it. We don't know what to do with it. He goes up and says, well, this looks a lot like the stuff I see at the hospitals. Have you looked into studying radiology? And it was one of those sort of magical meetings of what are the likelihood of these people coming together. And of course, that's where I come in. And I was Alyssa's undergraduate astronomy major student. I was looking for something really cool to do for my thesis and to do as a project. And I hear her casually telling me this, encounter. And I'm like, well, why can't we use astronomy data in medical imaging software? Why can't we put them together? And so there was my thesis project. And serendipity, sort of the magic of scientific discovery. You hear about this a lot. You read about famous people, penicillin, things accidentally getting discovered. There's also something to be said about people or other scientists accidentally coming together and meeting up. And it's sort of a magical thing and very key for science. So we're going to do a little quiz here. We're going to see how good you are at determining astronomy images from biomedical images. And I'm going to put two images on the screen. One of them was taken with a telescope and looking at something, thousands of light years away. The other is a microscope image, a confocal microscope image of a part of the human body. So the question is, between these two images, think for a second, which one you would say is astronomical and which one you would say is biological. And it's fun. I get to tease doctors and astronomers and make them guess the wrong thing. So you all get to do. So just who thinks for the image on the left, who thinks that's an astronomical image? Okay. And who thinks it's the one on the left is biological? Raise your hand. Close to 50-50. Well, the answer is the one on the left is biological. The one on the right is astronomical, and sort of know what these are. The one on the left is a close-up microscope view of the human cornea, sort of looking at the very thin outer layer of the human eye. And then the one on the right is a star-forming nebula called NGC 1333, and there's a pretty astronomy image of what you would see with a really, really good amateur telescope, or you'd see something similar in the night sky. So this is sort of what we're looking at. It's like, wow, these are really similar. Well, where's the data come from? So for the biological stuff, here's an example of an MRI scanner. The patient lies in the middle. They move, they're in the scanner, and you get this data set. And you can see in the upper left there for the images, the guy's nose, and you can see his mouth. And then you can sort of see that the scanner's stepping through his head. And then in the bottom right, it's showing the back of the head. Well, astronomers do the exact same thing, particularly radio astronomers. So here's an array of radio telescopes, and the upper left corner represents the very front of the nebula, and the lower right is the back of the nebula. And between the imaging, the data processing, what people are looking for, the astronomers are looking at those black and white images, looking for those young stars, which you can see some clusters in those dense white areas. They're looking for that. The doctors want to take the brain and find where all the different anatomical parts are. So same mission. So why not work together? And to further show you an example, this is classic Hubble image, Pillars of Creation, my favorites. But it's probably